This is Saxon's second edition, Algebra 1/2, Lesson 111, and this lesson is on simple and compound interest. Now this is one of those lessons that I will tell you for life, for adult life, you really need to understand the difference in simple and compound interest. It could save you a lot of money when you go to get loans on things like cars and different things. So look at example 1 on simple interest. Jim put $5,000 in the bank for 2 years in a savings account at 8% simple interest. Now, this is old, okay, because nobody's paying 8% interest anymore. It's way, way, way less. But for the purposes of explaining the concept, we're going to say he's getting 8% simple interest. So after 2 years, when he goes to withdraw his money, how much does he actually have in the bank? Well, to figure that, you would say his rate, which is 8% or 8/100ths, times the amount of money that he put in the bank, which was $5,000, equals 400. So basically, this says that the bank is going to pay him $400 for the use of his money each year. And they loan that money out. And for the privilege of them loaning it out, the people they loan it to are going to pay interest back. Now, you better believe if they're paying him 8%, they're going to get charged somebody else 10 or 12% for the use of the money. So they are making money on that. But so is he. He's going to get back $400 each year at simple interest. So he'll have a total of $5,800 at the end of 2 years. Not bad, right? Okay, next example. Maria deposited $800 at 8% simple interest. At the end of 3 years, how much money will she have? Well, again, it's rate times the amount, and her rate is 8% times the amount she put in as 800. So she's going to get $64 a year. Now, at the end of 3 years, she'll get 64 times 3, which is $192 in total interest. So when she goes to withdraw that, she's going to have the original 800 plus $192 for a total of $992. Now, remember this. Let's compare it with compound interest. All right. In the previous example, Maria had earned $64 simple interest at the end of a year. So at the end of the first year, she had a total of $864. If the bank is paying her compound interest, then the second year they would pay her 8% on the total amount, not on the original $800, but on the new amount, the new total of $864. So in the second year, she's going to earn not $64, but 8% times 864, which is $69.12. So now she's going to have the 864 at the end of the first year, plus an additional $69.12. So now she's got $933.12 at the end of 2 years. But she left it in for 3 years, so at the end of the third year, at compound interest, at the beginning of the third year, she's going to have $933.12, and they're going to be paying her 8% of that, the third year, which is $74.65. So you see, in compound interest, the amount of interest you get each year is going to be a little bit more because your original amount is going to be different at the beginning of each year. So if she were being paid compound interest, at the end of 3 years, she would have $1,007.77. Now, what's the difference in the two? In simple interest, she received $992 at the end of 3 years. But at compound interest, she received $1,007.77. So there's a difference of $15.77. Now, granted, that's not a huge difference on an original amount of $800, but imagine if that were $8,000 or $80,000, then you're talking a whole lot of difference, okay? Okay, example 3 says, how much would $7 $700 be worth in 2 years if the money is deposited at a 9% interest compounded annually? So this is compound interest. So the first year is no different than simple interest. It's 9% of $700, which is $63. They add that $63 to the $700. So at the end of the first year, they have $763. Now, beginning year 2, your original amount now is not $700, it's $763. So you multiply that times the 9%, and that next year you're going to get $68.67 in interest. So you're going to add that to the $763 that you started year 2 with, and you're going to have, at the end of year 2, you're going to have $831.67. Pretty good. Okay, so your first practice problem says Elvira put $7,000 in the bank at 9% simple interest. So her rate is 0.09 times $7,000. That equals $630 in interest that she's going to make that first year. Now at simple interest, they're going to be paying her on this amount every year. So for 2 years, that's $1,260. You add that to the original $7,000, and at the end of 2 years, she's going to have $8,260 in the bank. So let's compare that to now she's going to get 9% compounded annually. So we're still going to say 0.09 is her rate and 7,000 is her original amount. So the first year is actually not going to be any different. She's going to earn $630 that first year. But now beginning year 2, she now has 7,000 plus the 630 for a total of 7,360. So that the beginning of the second year, 0.09 times $7,360. Let's see, she's got 0.09 times 7,360. So the second year, her interest, instead of 630, is $662.40. So now we're going to add $7,360 and $662.40. So at the end of 2 years in compound interest, she's going to have $8,022.40. Okay, good job. Some people have said it's a little confusing, but again, it is extremely important that you understand the difference in simple and compound. So if you're going to put your money in the bank in a savings account, you want compound interest instead of simple because you're going to make more money. However, if you're getting a loan where you're going to have to be paying back money, you'd rather have a simple interest loan rather than compound because it's going to be a set amount of interest based on the original amount that you borrowed. Okay? Good thing to keep in mind. See you next time for lesson 112.